Welcome to the intro to Unit 4, where we're going to talk about fractions in overdrive, the path to rational expressions. So in this unit, we are going to be talking about rational expressions. But we just want to review a little bit about those fractions and how to add, subtract, multiply, and divide. Just those basic fractions that you worked with previously in previous years. So let's take a look at our objective. By the end of this lesson, you can actually add, subtract, multiply, and divide numerical fractions and explain how replacing the number with a variable creates a rational expression. A fraction shows part of a whole. The top number, the numerator, counts the chosen parts, and the bottom number, the denominator, tells how many equal parts make one whole. So writing 3 over 5 means 3 out of 5 parts. Multiplying both numbers by the same non-zero integer creates an equivalent fraction with the same size. So let's take a look at an example for that, because that's very important as well. Just go back here and take a look at what we're talking about if we multiply both numbers by the same non-zero integer. Creates an equivalent fraction. So if I multiply the top by 2, I'll change my color here. The top by 2, I have to multiply the bottom by 2. Essentially, I'm just multiplying by the number 1. 2 over 2 is 1. So that would equal an equivalent fraction of 6 over 10. So these are the same fractions, one simplified and one is just multiplied by 2, but they are equivalent fractions. All right, so adding fractions, multiplying fractions, dividing fractions, that's what we're going to talk about here. So let's just keep that in mind and move on here to the rules. So when we're adding fractions, you have to find a common denominator. So you're going to want to list the smallest number that both denominators divide into, and this is the least common denominator. Just refreshing your memory here. When you're multiplying, you to scale the numerators to match, when we're finding common denominators, you have to scale the numerators to match. So you want to multiply each numerator and denominator by whatever factor makes the denominator equal to the least common denominator. All right, so let's just do an example of a number here, since that's just a lot of directions without an example, right? So say I want to add 3 over 5 plus 2 over 3. What is the smallest number that both denominators divide into? And that is what our least common denominator. So we're looking for our least common denominator. I know that multiples of 5 are 5, 10, 15, 20. Let's just do 4. And then our multiples of 3 are 3, 6, 9, 12, 15. Oh, I'm going to stop there because I have a 15 that they are both able to divide in. So that's going to be my smallest number. So I want to turn my denominators both into 15. So I need to multiply each numerator and denominator by whatever factor makes the denominator equal. So how I turned 5 into 15 on this first term is I multiplied it by 3. So I need to multiply the top by 3 also to get my new numerator. So 3 times 3 would be 9. On this side, how I came up with 15 was I had to multiply the denominator by 5. So I have to multiply the numerator by 5 to give me 10. All right, so now I have common denominators. Now I want to keep the denominator the same and add the adjusted numerators to get the new top number. So keep the denominator the same, add 9 plus 10 to give me 19. And then we want to simplify the fractions. If both the numbers share a fraction greater than 1, divide to write the fraction in simplest form. Well, I am going to take out, this is going to be 1 and 4/15. The numerator and the denominator on 4/15 does not have anything except for 1 in common, so I would not need to simplify it any further. However, if it was 3/15, I would have a 3 that they would have in common, so I would divide out 3 from both of them, leaving me with 1/5, because I divided the top by 3 and I divided the bottom by 3. All right, I hope you remember all of those rules that you have learned in the past about adding and subtracting fractions. Let's practice. What is the least common denominator of 2/3 and 5/12? 2/3 and 5/12. So I have 2/3 and 5/12. Well, I would think that the least common denominator is going to be 12, right? So I need to turn this one into 12. So what did I multiply 3 by to get 12? If you said 4, you are correct. So I need to multiply 2 times 4 to get 8. To get 8. So now I have 8/12 and 5/12. They have the common denominator. I can add or subtract them. So 12 would have been my answer here. When we want to multiply and divide those fractions. Well, when you're multiplying, you are doing it straight across. So you are multiplying the numerators times each other, and you're going to multiply the denominators times each other. That is all that you would do. You do not have to find the common denominators or anything when you're multiplying on those. So if you had 2/3 times 3/5, I would just multiply 2 times 3 to give me 6, 3 times 5 to give me 15. I noticed that those can be simplified by dividing them both by 3. So I would do that and give me 2/5. So that is how you multiply fractions. When we are dividing fractions, you're actually going to turn it into a multiplication problem. So let's just look at that same set there, but we're going to put a division sign in here. 2/3 divided by 3/5 is the same as 2/3 times 5/3. So what we do is we keep the first term, we change the division sign to multiplication, and we flip the third term. So keep, change, flip. Multiply by the reciprocal. Multiply by reciprocal, okay? And then you just do the multiplication, same steps, straight across. 2 times 5 is 10, and 3 times 3 is 9. That is our multiplying and dividing, so you know how to add and subtract and multiply and divide your fractions. All right, let's just move on here and talk about changing the numbers to variables. What happens when we replace a number with a variable? We turn it into an expression, algebraic expression. So instead of 5/8, we have x over 8. So we have an unknown variable. This is now called a rational expression. Rational expression. This is a fraction. This is a rational expression because it has a variable in there. And we are going to learn in this unit how to manipulate and solve rational expressions using those same rules that you use during multiplying fractions, dividing fractions, adding and subtracting fractions by finding those common denominators and doing some other manipulations to make equivalent expressions. So you're going to be doing that later in this unit. I will show you one more thing here, just some more examples of rational expressions. You can have numbers over a linear binomial. You can have squares plus other numbers over trinomials. You can get very, very messy, shall I say. You can get very complicated, from very, very simplified to very complicated polynomials. These are both still called rational expressions. That's everything in this introduction that you need to know and before you start on your unit 4, lesson 2. If you have any questions or you need some practice about multiplying or dividing just regular fractions with numerical integers in both the numerator and denominator, reach out and we can give you some help in IXL. Have a great day.